First, a reminder, a rate law can only be determined by experiment. You cannot simply look at the balanced chemical equation and write the rate law. In this case, there's 2 reagents, so we have to choose trials in which one of the reagents' concentration is the same. For example, if we look at the first 2 trials, we see that the concentration of chlorine has remained the same, and the concentration of NO has increased by a factor of 2. When we look at the rate, we see that the rate has increased by a factor of 4. So that means that this reaction is second order with respect to NO. Now if we look at the second and the third trial, we see that the concentration of NO remains the same, whereas the concentration of Cl2 has doubled. When we compare the rates of these 2 trials, we see the rates of the 2 trials has increased by a factor of 2. Accordingly, we can conclude that the reaction is first order with respect to Cl2. Now we have enough information to write our rate law, because we know that the reaction rate is going to be equal to K with a second order dependency on NO and a first order dependency on chlorine. As a last step, we can plug in the values for any of these 3 trials to determine the rate constant. We solve our expression for K, and we see that K is going to be equal to the rate divided by the concentration of NO squared and the concentration of Cl2. Now we can plug in data from any of the 3 trials to get an experimental value for K. Numerically, our result is 9.12. Let's take a look at the units. Liters, cancel with liters here. Moles with moles. So we have liters squared per moles squared hours. And as far as sig figs,